Good day, this is Jessica Steele, please IT3A. Today's video, I'm going to do the activity 9.6.4 switch operation. Task 1, observe how a switch processes a broadcast and unknown unicast. Complete the spanning tree protocol by toggling between real-time and simulation mode 4 times. All link lights should turn green. And now it's turned green. Step 2, open ERP and Mac tables. Using the Inspector magnifying glass, open the ERP tables for PCE and PCB and the Mac table for the switch. So, we were using the magnifying glass. Click the PCE, PCB, and the switch. Mac table. We are not interested in the ERP table for the switch at this time. It is related to the switch management interface, which will be covered after. Move the selection arrow over the switch to view a summary of the switch ports under interface MAC address. Please note that this is not table of addresses that in the switch learns. Arrange the windows above the topology. So let's arrange this. And then the PCB. Then step 3, add a symbol PDU to ping from PCE to PCB. Use the add symbol PDU, the closed envelope, to send a single ping from PCE to PCB. Click on PCE, the source, and then click on the PCB, the destination. By using the sample PDU, click the PCE and PCB. By clicking it, the two events appear in the eventless field, an ICMP AQ request and an ERP request to learn the MAC address of PCB. Click on the colored box in the info column to examine these events. First, I'm going to click the ICMP. The ping process starts the next ping request. The ping process creates an ICMP AQ request message and sends it to the lower process. The source IP address is not specified. The device sets it to the port's IP address. The device sets TTL in the packet header. The destination IP address is in the same subnet. The device sets the next hop to destination. Next is the ARP. The ARP process constructs a request for the target IP address. The device encapsulates the PDU into an Ethernet frame. Step 4. Step through the simulation. Use the capture port button to trace the resulting sequence of packets. Click capture forward. Since the PCE ERP table has no entry for PCB, in order to complete the ping, it must first issue an ERP request. The switch learns the MAC address of PCE and the port to which it is connected from the ERP request. It learns the MAC address of PCB and the port to which it is connected from the ERP reply. The switch flags the ERP request out all ports because ERP requests are always broadcast. Once PCE receives the ERP reply, it can complete the ping. From the perspective of the switch, the ping is a known unicast. When you are done tracing the packets, click the reset. When I click the capture forward, the switch appear the MAC address VLAN 1 MAC address 000 and the port was Ethernet 01. Bus Ethernet 01 receives the frame. Let me see. Then click the reset simulation. Next, task 2. Observe how a switch processes a known unicast. Clearing the switch MAC address table. Click on the switch. Click on the CLI tab. Switch CLI tab, and then at the command prompt, press enter key up. At the command prompt, press the enter key a few times. The switch prompt will appear. Type enable and press the enter key. Enable. Enter. This should change the prompt to switch number. Type the command clear MAC address table dynamic. Clear. Clear address table dynamic. Clear MAC address table dynamic and press the enter key. Note that the MAC table for the switch that you displayed earlier is once again empty. However, the PC ERP tables are still populated. Close the switch configuration window. Close. Next is step 2. Resend the packet. You should still be in simulation mode. The user created with you. The ping from PC A to PCB that you created in task 1 is still in the event list. It's still here. Use capture forward button to trace resulting sequence of buckets. Click capture forward. Because the ERP tables are populated, no ERP request broadcast is necessary. But when the ACK request packet reaches the switch with its empty MAC address table, it is now considered an unknown unicast. In this case, the switch floods the packet out all ports except the port it was received. First, click the colored box. When done, delete scenario 0 by clicking the delete button. Delete. Next is task 3. Observe switch behavior in other situation. Ping through a hub. Now try pinging from PCE to PCF using the add sample video button. Ping the PCE and PCF. Trace the packets to try to understand what is happening. Note the switch learns that two MAC address exists through one of its ports. And it learned this because the hub is forwarding all packets to the switch. The ARP process constructs a request for the target IP address. The device encapsulates the PDU and it into an Ethernet frame. Save to experiment for other experiments to learn what algorithm the switch is using to process frames. So that's all.